So on this last day of notes, this example is called 1. We're going to change that to example 2. It says that we need to write an inequality for x. So if we look to see what we're given that the angle is 85 here. It's the included angle, meaning it's between the two sides given to us. And we're assessing this line segment, x. Okay, from this angle, 65. Also, it's the included angle between the two segments given. It is across from 12. So we're assessing this line segment as well. So I want to know, is x less than 12 or is x greater than 12? Well, I base it off the angles. So 85 is bigger than 65. That means that x is going to be greater than 12. And letter B, same ideology. For 35 degrees, we're going to look at this x value. And at 20, we're going to look at the 16 value. So I want to know, 35 is bigger than 20. So that means x is greater than 16. Okay, in example 2, it says, using the converse of the hinge theorem, what is the range of possible values of x? So first is going to be example 3. And then the range of possible values of x. Well, this is a little bit tricky. We have to set up two different inequalities. So first, from this 60, we're going to be looking at the 15. Okay. Then, from this 5x minus 20, we're going to be looking at the 10. Okay. So, if I compare these, the 5x minus 20 is across from 10. This is across from 15. 10 is smaller than 15. So I'm going to say that this angle is less than this angle 60, based on 10 being smaller than 15. Okay, so this is less than 60. So if I solve this, we get that x is 16. Okay. All right, then we also know that the angle measurement here cannot be 0 degrees, and it can't be anything less than 0 degrees. So we know that this angle has to be greater than 0. Okay, it can't be equal to 0, can't be less than 0. So I'm going to say 5x minus 20 is going to have to be greater than 0. And if we solve that, we get x is greater than 4. Now, we want to put this into one inequality called a compound inequality. So the official name is a compound inequality. And there are two types that you would have learned in algebra. There's the ands and there's the ors. And we're going to write an and. So I put my least number here and my greatest number here, and x goes in the middle. We know x is less than 16. We also know that x is greater than 4, but I actually write it as a less than sign because x greater than 4 down here is flipped around. It says 4 is less than x. It is flipped around, the 4 and the x, which means that you have to flip around the inequality. So the range x could be is between 4 and 16. So I could plug in 5, 6, 7, 8, 9, 10, etc. up to 16 into this, and that would be one of my answers. All right, now for part B. Okay, so now let's compare. We have this to 22, and we have this angle to 25. All right, now 2x minus 18. We need to decide, is it less than or greater than 32? Okay, well 22 is smaller or less than 25, so this angle is less than 32. And then lastly, I know that that angle, 2x minus 18, It has to be greater than 0. Okay? So now I can solve each one. Now on this one, we add 18, and we get 9. Alright, so now, again, it's a compound inequality, just like this. It's an and. We put the least first and the biggest number last. X is in the middle. And we have x less than 25. And because this part is flipped around, we flip it around. Because these symbols, inequality symbols, have to be going the same direction when you do this problem. So again, what can x be? It can be anything in between 9 and 25. It's within this range.